This is 2009 AP Physics B exam question, which is equivalent to 2000, which is AP Physics 2 exam questions would be like. And if you want to read the question and try to answer it before you see the solution and explanation, that's probably the best way to learn. And if you make mistakes, you learn from them. So go ahead and pause anytime, solve the problem, and then watch the video, watch the explanation. So the question states, 3 objects of identical mass attached to the strings are suspended in a large tank of liquid as shown above. Must all 3 strings have the same tension? Think about the question. Think about what the answer would be and why. Pause it if you need to. And I'm going to give the answer right now. So the answer would be a no. A no. And the explanation is this way. I'm going to show on the B version. So here is your tension. Here is your mg. They all have the same mg. So here is the tension. Here is mg. So again, every single one of them has mg, but they all have different tension. So this is tension A, this is tension B, and this is tension C. But they also have the buoyancy force acting on them. So the buoyancy force of this one, BA, this one has the buoyancy force acting on this one, B of B, and this one has the buoyancy force acting on this one, BC. So the generic equation, the sum of all the forces, the net force, is equal to ma, and there is no acceleration, second Newton's law, or Newton's second law. The sum of all the forces, so I have generic tension minus mg, but plus the buoyancy is equal to 0. So the tension for every single case is different, equals to mg minus the buoyancy. But the buoyancy is different for every single one of them because the buoyancy force is equal to the weight of the water or the weight of the liquid displaced. So, and the weight of the liquid is equal to mg of that liquid. And mg of the liquid is equal to the volume of the liquid, the density of the liquid, and g. And this is the trick. The volume that is misplaced by the by each object is different. VA, VB, and VC have all different volumes. That's why every single buoyancy is different. There is A and B and C buoyancy. So there is A and B and C volume. So every single tension is going to be different. So the answer is a no. So for B part, they say an object has a volume and the density and the tension in the string. Find the buoyancy force. So for B, I have again the tension or the buoyancy is equal to mg minus the tension. The mass of the body is, or the object is equal to its density times the volume, g, and because the density formula is equal to how much mass per volume, so the mass is equal to density times the volume, and minus the tension. So we have the density is 1300. The volume is 10 to the negative 5. G is 10, and the tension point 0.098. So I get the buoyancy force is equal to 0.13 minus 0.0098, and that gives me 0.12 newtons. Next question C is asking you to find the density of the liquid. So I know that the buoyancy force is equal to the mass of the liquid. So I have it right there on the side. It's the mass times, it's the weight of the liquid, right? So it's the weight of the liquid. So it's the mass of the liquid. Mass of the liquid is equal to the density of the liquid, not the density of the object. It's the density, let me write it L for liquid. The density of the liquid, I'm going to write L right here for the liquid. And this is the object of this sphere. So this is, I'm just going to write a sphere right there. So this is the liquid. The volume of the displaced water, which is the volume of the object that they give you the volume already, and times G. And I already found my buoyancy force. So what I have is 0.12. The buoyancy force is equal to the density of the liquid that they ask me, the volume of the displaced water is equal to the volume of the water of the object that was placed in the liquid. So that is 10 to the negative 5 and times 10. So the density of the liquid is going to be equal to 1200, and the density is the mass per volume. So it's kilogram per meter cubic. So the density is kilogram per meter cubic. For D, some of the liquid is now drained from the tank until only half of the volume of an object A is submerged. Would the tension in the string to which object A is attached increase, decrease, or remain the same? So now you have, I'm going to redraw this. So you have an object A and only half of it submerged in the water. So you have the tension, you have mg, and you have the buoyancy force. And the buoyancy force is equal to the weight of the volume of the weight of the water that is being displaced by the object when it's placed in the water. So in this case, you have the weight of the water is, or the liquid, is the mass of the liquid, G of the liquid, or G, acceleration due to gravity, and the mass of the liquid is the volume of the liquid that's being displaced, and the density of the liquid. And the volume that is being displaced is only 1/2 of the volume of the sphere, the density of the liquid. And then G, forgetting about the little G. So it looks like the buoyancy is going to be less now than it used to be. Before, the volume was full volume that was displaced with the water. Now it's only 1/2. So that means the tension is going to increase because the buoyancy is not as strong anymore. So the tension does not have as much support from the buoyancy. So it will feel more weight pulling down.